Okay, so I think we're going to go ahead and get started here. Thank you for joining today. And so I'm Elizabeth Bittinger. I am the Director of Graduate Studies in Chemical Engineering at the City College of New York, and also an assistant professor there. And so today's topic is, what is it like to do a PhD? And it's part of our series, a conversation with CCNY Chemical Engineering PhD students. And we have 3 PhD students that will be joining us today. I'm going to go ahead and stop sharing so that we can focus on them a bit. Let's see, how do we stop this? Not a new share. Always have to figure out how Zoom works. Okay, so I'm going to go ahead and suggest that our 3 speakers today go ahead and unmute and turn on your cameras so that we can get started. And Alex Cruzes, you can too, so that we can introduce you, and then we'll come back to you in a bit too. So what we have is we have Yinka Leslie, we have Jalen Liu, and Andrew May are joining us as our PhD students from CCNY, or City College of New York. Thank you for joining us today. And then also co-moderating the session is Professor Alex Cruzes, and he is he's going to also be the one fielding the questions. So if you have any questions today, please send them to Alex, and he will be able to interrupt us when we are ready to take questions, and so that we can either have you ask them or we can ask them for you, depending upon how the technology goes. And so I'm going to go ahead and get started. All right, so I think we have to start out with some proper introductions. And so I would like each of you to, in 1 or 2 minutes, to give a little introduction about yourself, where you're from, what year in the program you're at, what's your research topic, who do you do your research from, with, your undergraduate institution, and any other information that you wish to share to start us off. Yinka, would you like to start?
No problem, thanks. So my name is Yinka. I'm a 6th year PhD student. So, and I was born in Nigeria, but I grew up in Madison, Wisconsin. And I also went to the University of Wisconsin-Madison for my bachelor degree in chemical engineering. And after that, I actually worked a bit in a small biotech biofuels company in Madison called Virent. And then I joined in 2014, joined City College. I worked with David Rumchinsky in the Rumchinsky group. We research the cancer growth. So it's you can think of it as kind of a mathematical oncology. We also look at medical image analysis, and I guess a little systems biology, although we're not too much. We're more into modeling than biology per se, but that could change. I think that's a pretty good summary.
Okay, thank you. Shailin, would you like to introduce yourself?
Yeah. So my name is Zilo Liu. I'm the 3rd year PhD student in CCNY. I'm from Taiwan. I went to the undergrad degree there in chemical engineering in National Taiwan University. And I also went to military service for 1 year, and then Cornell, Ithaca, for a master program in chemical engineering, and then here. Yeah, so I joined in 2017. And I'm in Dr. Xu Chen's group. And my research is about water responsive material, which means that our material will react to changing humidity, pretty much that. And I guess that's pretty much it.
Thank you. And Andrew?
Hi, I'm Andrew. I'm a 2nd year PhD student, and I'm working in Professor Bittinger's lab. My undergrad I did at the University of British Columbia on the west coast of Canada. That's also where I grew up. Yeah, so now in Professor Bittinger's lab, I work on electroreduction of biomass-derived species. Specifically, I'm studying kinetics and mechanisms of the reactions. And I guess I have a bit of work experience between the start of the PhD and the end of my undergrad, as well as a co-op experience during my undergrad. And yeah.
Okay, thank you. And thank you again for joining. So today's topic is all about what it's like to be a PhD student. And so each of you are in a different point in your PhD careers. Yinka, you're getting ready to graduate soon. Jaylin, you're in the heart of all the research. And Andrew, you're finishing up those last few classes and really getting into the research, kind of starting that deep dive now. And so I think this is a great group to have this perspective. Andrew, I'll let you start since you are highlighted here at the moment. How would you describe your experience being a PhD student so far? And what do you generally spend your time on right now, or typically?
Sure. I think the first thing I know for like the PhD experience is it's more challenging than I expected. And maybe I should have expected it, because that's pretty much what people told me when I was in my undergrad. So I think that's good though, like having something to do. Sometimes like in some of the co-op and work experience I've had, you run out of stuff to do and you kind of want to be like have a challenge or like a goal to reach for or other. I guess the way I spend my time, I'll say how it went like before the quarantine happened, because that's kind of probably more typical of what would happen.
Sounds good.
I think what would happen is most days I would try to get some experiments done in the morning. So I'd usually come in like 8:30 or 9 to set up the experiment and carry it out. And it usually would end between 12 and 1. And that's kind of where I take the lunch break and talk with some of my friends in the offices and etc. After that, I usually do like some of the data analysis or literature review, or if you're writing like any reports or manuscripts. And then I guess what I remember most recently, like the start of this semester and last semester, I was done most of like the hardest courses. So less of my time was spent on coursework. It'd probably be like maybe an hour a day is all I'd have to spend, which is nice. It's nice to be doing, I guess, more research. And then, yeah, after doing like the data analysis and lit review, etc., I'd go home and eat or go out with friends to eat, and then either like hang out, do nothing, or go to the gym, or go climbing, or kind of whatever you want to do to, I don't know, move around a bit and have some more energy. Otherwise, it gets like really tiring over the time, or like of a week. If you just do work, it gets hard to do work. So I don't know. For me, I just have to do something. Otherwise, I get nothing done ever.
And then as a contrast, you said that you were finished with your most of your courses. So how did that compare to in the first year when you were doing so many of your courses?
Let's see. I guess in the first year, you try to make, well, what my cohort and like me and my friends, we would all take the same classes for the most part. And then electives, I think we were usually, we were kind of split between 1 or 2 electives. So like some of us would go one and some of us are in the other. And then we kind of try to do like study groups and et cetera to have, I guess, a better time studying and getting through the material. Because a lot of us are better at the different subjects. So to kind of have their perspective and their like they have a better expertise, I guess, in some subjects, they can kind of speed up the process a bit, and the stuff that's like hard to explain, they can give like the, I guess, what works for them or like the tricks. And then likewise, I can help them with the subjects I'm stronger in. And it makes it a lot more fun because studying's hard since it's a bit different than the undergrad experience. The classes are like they're trickier. The homework is very challenging. And I guess compared to my, like where I went to undergrad, there was like a bigger body of students. So it would be like a class of 80 maybe, and you can go to the computer lab or et cetera, and your whole year will be doing homework. Whereas here, my cohort was like 6 people. So it's, you have to, I guess, go out of your way more, like try more to get everyone together, which isn't too hard. They're willing to. You just have to let them know that you would like to study together. And yeah.
Right, thank you. Jalen, you want to comment on what a typical day is for you?
Yeah. So, I mean, before the quarantine, I usually go to school at 9:30 to 10-ish and do some work. So my experiment, I have to go to clean room. Also, a lot of chemistry things. Also, some technique that, like surface science suites. So I usually spend like 5 or 6 hours in those places single day. And so my experiment usually can be finished before 4 or 5. But I usually stay there and just analyze data, read things. And also I have a lot of undergrads to mentor. So I usually have to, I mean, on average, maybe 30 minutes per day. Yeah, to just talk to them. Yeah, and the rest of that is just reading, analyzing, some meeting with professors and chat with other coworkers. Yeah, so after all those things, it's probably just like 7:30. I just go home and take a rest. I go to gym a lot after that and eat a lot, which is like make me just refresh my mind so I can be productive the other day. So that's pretty much a typical day. Yeah.
Thank you. And Yinka, how about you?
Yes. Okay. Well, I guess in my work, I do a lot of simulations, a lot of computer work, but at the same time, I have done some experiments. So I have to kind of divide this into 2 different types of days. So in my most typical day, I go to, my desk, I have a computer, I start coding. Usually I'm doing data analysis or writing scripts to run those analysis, or I'm monitoring the results of those analyses and I'm making plots. So that's the brunt of my day, really. I also talk to my mentor, David. Sometimes it's just, because obviously his desk is also on the same floor. I mean, his office is on the same floor I work in. So sometimes it's just 10 minutes talking. Sometimes it's a longer hour meeting. Or once in a while, I just wave at him as he walks by. Right. There's some of that stuff. I also kind of try and look at some literature. Usually there's some useful equations or information I might need. And recently, I'm also working on writing my thesis, right? So that involves like compiling material and I'm sorting everything and doing the actual writing. And, I won't go too much into that. Okay, on the other aspect of it is when I work with experiments, or when I do experiments, my experiments have been basically taking pictures of zebrafish that have been inoculated with melanoma. So you can imagine, there's no zebrafish facility on campus. So I have to travel across town. So that adds basically an hour to get to the west side, the east side, and another hour to get back. And then basically I go to the facility, which is in the basement of this building on the upper east side. And it's a lot of standing to work with the fish, starting out, gathering the fish and materials, and then sitting with the microscope for maybe 3 to 4 hours in a dark room, taking photos. And so that's a bit more tasking physically. But it is a good, something different, right? And, you go to a different part of town, so it's not that bad. Yeah, so, and, okay, I think right. I think Andy and Jaloon talked about also some of the more extracurricular activities or what to do to take breaks. Mainly, like, while I'm at my desk, usually in the middle of the day sometime or in the evening, I just take a walk to get lunch and maybe there's a cafe called Cafe One that everybody frequents. So walk down there, get a treat, and then walk back. And it's just nice to take a break that way. Of course, like they all mentioned that we hang out together, especially with people that came in with us, right? So I sometimes not so much for me, but once in a while there's a get-together bar or some other events, or sometimes you just want to go to lunch together, and that's always nice. So it's usually a pretty well-rounded day.
So I'm going to come back to that. You say you work with zebrafish. Why do you do that again?
Oh, right. Okay, sure. We're studying cancer growth, right? So we need some animal. Well, you could take data from literature, from like people's medical scans, but we wanted to actually do experiments and control how the cancers grow. And you have the option of doing it in mice or rats, or we chose zebrafish because zebrafish kind of reproduce a lot faster. You can study many more of them. And there's also this issue of how do you actually detect the cancer since they're under the skin usually. Sometimes they're not, but usually they are, especially when you want to look at how cancers metastasize, right? So those cancers can be anywhere within the body. So these zebrafish are kind of yay big, maybe a little smaller, and they are transparent, or translucent really, because they've been bred to lose their stripes. Obviously, usually zebrafish have stripes, but this ones don't. And that means that when you have a fluorescent tumor, which you have to have that as well, you can actually just look through a microscope and see the light from those tumors. And you can kind of map out where in the fish the cancer is. And that allows us to collect a lot of data that I then go back to my desk and analyze.
Okay. Thank you for clarifying. Yeah, I definitely never worked with fish in my PhD studies. I don't know the other guys, but that's cool. Okay. So maybe you can talk a little bit more about, you're getting ready to graduate, so you're thinking about, well, not just thinking about, you're actively writing a thesis right now.
Yes.
What's the process that you have to go through to be able to write the thesis? That's a hard question, right?
To be able to write a thesis. So, I mean, part of that is, right, obviously you have years of stuff you've accumulated that hopefully you've kept somewhat organized. I mean that, when you've done experiments and you've analyzed them and you produce a chart or you have some results and you present it to your mentor, right? You should probably save those because those might, either go in the paper on your thesis. At the same, so, basically, I know a lot of lab groups have weekly meetings where they present, some results. So those can actually be useful in building up a lot of material you can reference later. So that's one thing. So a big aspect of it is just making sure you have material from the past that makes your life easier. Another aspect of it is you need a lot of background information, I guess. So in the same ilk as you go on through your research, you should have a long list of papers you've read and you've looked at. Maybe you have a summary of what's in those papers, or maybe you don't, but at least you should have them and have an idea what's in them. Okay, but so that's the and yeah, so that's kind of the fundamentals you need. But to actually, I guess, write the thesis or to begin writing it, I mean, you have to outline. I mean, I guess people have different styles, right? But I guess what I've talked about with David is you have start with a basic outline, and then you have, I guess, you can refer back to those plots and diagrams you've made, the results essentially, right? And obviously the thesis has different sections, but I'll focus on the results section. Each of those plots, each of those results is something you can write around. So really in your outline, you can first, start with some bullets, but then you put in the results, the charts and images to kind of structure it, and then you start writing around that. Stuff like part of my research as well, I have a lot of, since I run simulations, but also we kind of have a mathematical model that takes some, that's novel, and we need to describe as well. So I have a lot of like equations and derivations I've also kind of accumulated over the years that I also have to add in. So there's gonna be, there is, and I need to do more of it, of just kind of actually some kind of mathematical derivations that maybe is different than some of the people at City College. Okay, I kind of meandered a little bit about
That's okay. This is what happens. You are deep in it. You are deep in the process, right? And so that's probably what you're thinking pretty all-consuming about. So Jaylun and Andrew, you are a little earlier in your career, maybe not quite ready to write a thesis, right? But you did just, for Jaylun, you took your second exam, which is our version of the candidacy exam, which is a proposal, right? You took that fairly recently. Yep. And then Andrew, you are getting ready to write yours. So this is kind of the other end of preparing and proposing your research. Jaylun, do you want to talk a little bit about what goes into creating a proposal of your research?
Yeah. So to write my second exam report, which is about the research proposal, I've proposed like 3 ideas, but most of them, actually the first one was actually the thing my professor, my mentor, Shi Chen, asked me to do. So I just complete that and then talk about the result there, and also include the motivation and discussion in the report. But there are 2 other things. And the two other things, I've been challenging him a lot, actually. So I sometimes propose things to him, and he would say that this is not good at all, and now he just give up. But after several times of challenging him, some good ideas comes out, and so actually the good idea, a lot of them are still from the professor, but some of them are my ideas. So that's kind of how I form the ideas. So I just throw them in the proposal. And one of the, there's also one idea, which is about a device that was originally a project for undergrad students, which is to promote STEM community. And it just happened to just very closely match my other projects. So I just kind of like integrate all of them together to form a very big picture. So that complete that forms like 3 ideas and complete the whole proposal. And so I guess the whole process is actually takes maybe a year-ish. But to really like hand on preparing, writing things for the proposal, it took me like 2 months, especially for the. So I said that there are 3 ideas, and the last one was that comes out from a lot of challenging back and forth with my professor, and that one just because no one has done that before, so I spent a lot of time reading things about that, and also like Yinga just mentioned, just document a lot of papers that could be relevant, and I also read a lot of things that are irrelevant because the idea is not complete yet. Yeah, and then spend the last month just writing things, analyzing things, and that sometimes I did a lot of calculation, but I only include just a small portion of that into my report because that ends up to be more relevant. So some trial and error, a lot of challenging between me and the professor. That's kind of how I prepare for my second exam, the proposal. Yeah.
And so now you get to actually do the research that you've proposed, and also find out how good the idea was, and test it out and change things along the way as you go, oh, well, that's really interesting, and such too. You experiencing that yet?
Yeah, it happens sometimes. So right after my second exam, I have some preliminary data that is completely new idea. After the second exam, I've been doing that, and I feel quite good about the progress. But then the quarantine starts, so so now I can just read more and then get more prepared for that maybe.
Yeah. Well, good luck with moving forward. And Andrew, you are on the other side. You are just really starting the writing process, right?
Yes. Yeah, I don't know. I think it's similar to what Alan has told us. I guess what I've been focusing on now is getting the outline set out and coming up with the new ideas and like what's actually going to be the new work. And it's a lot of, I guess, back and forth with Professor Bittinger. And then trying to, because it's not just like you get a new idea and then like you kind of go. First, like part of it's like coming up with the ideas. It's not like you just sit there and they pop up. It's usually through like, you have like a couple of meetings. You kind of get like part inspired when you're in a meeting, part inspired by like reading work, looking at your own results and kind of like understanding what your research even is and what's your goal. And then once you have, because you'll have like a number of ideas, which I have had as well, but then it becomes trying to make it like a story that could become a thesis. You don't want to have like a jumble of experiments because then you can't tie it together and like write something that is going to answer questions and I guess like progress your field in like a meaningful way. It kind of would just be like cool facts as a report, which is not really the goal. So working on that a lot, and it's going pretty good. And like the way I write, I guess like the proposal and how to make it flow is also challenging, because you want to make it, I guess, understandable to the reader who, I mean, I think my committee will know the material, but for things other than the second exam, you want your material to be like digestible by the readers, and that in itself has been challenging. But working with your advisor, you get through it. They help you out. They point the things out that like what my habits are basically in my writing, and what is usually like a good way for flow and etc. And yeah.
So it's about taking ownership of your research and getting excited and engaged about it and looking to the future of how you're going to spend your time, I think, right?
Mm-hmm. Yeah.
So we're about halfway through. We certainly have more conversation that we can have, but I wanted to check and see if there was any questions from the audience who had sent anything to Professor Kouzes.
Yes, we have a question from Mike Borello. Mike, would you like to ask the panelists your question directly?
Sure, yes. So when you are faced with a problem, and I mean, it could be something from anywhere from like a homework problem to maybe a problem in the lab or a problem that you don't understand equipment, I could take it however you will. But when you're faced with the problem and you've never solved it before, what's your hierarchy to figuring out how to solve it? Like, who do you go to first, or what do you try to do first?
Actually, can I go for this one? I mean, obviously, everybody can answer, but I like this question. Thanks, Mike. Right. That's a very quick question because that happens a lot, actually, I think. And I think different people have different approaches to it. And I like the question because I know I work with some other people in my lab group, right? And they have a different approach. And usually what I do myself is first I kind of try and look at, let's say, the fundamentals. Like I work with a lot of equations, right? So what I mean by that is, if you take, for example, the idea of, I guess you might have encountered, mass balances or whatever, right? So that's kind of a tool, or I remember in undergrad in chemical engineering, going through the textbook, making a shell balance and using those to derive the constituent equations for, fluid dynamics or whatever, or momentum balances. So I'm talking about stuff like that of, you kind of just look at the system, look at the inputs and outputs, and see how you can use that to go to address the problem. But the truth is, of course, somebody has already done it before you. So it is always a good idea to also look look in literature, and you should do both, kind of look at the fundamentals and look in literature or ask an expert, because that kind of helps you both understand it and kind of understand what other people have done and how the other people have approached a problem, like, even if it's a very novel problem, someone has already done something like it, or somebody has talked about something that you might not even realize is similar, but actually has some relationship to it. So, but I think, like I was saying, what is interesting to me is that people can have different approach. Some people might kind of look at the fundamentals first, like I do, but other people might kind of do the research first, Google or a journal, or ask a mentor and to kind of solve the problem.
So Arun, do you have, or Andrew, any comment on how do you deal with a challenge? Something like
Yeah. So my approach to problems, I think it depends a lot on the problem itself. I guess for problem about research, about new stuff, I guess no one knows the real answer to that. I usually I read a lot, and also I discuss with my advisor. Also, there's some research faculty they're so good at physics, so I discuss with them a lot as well. And but that's only for new stuff. Maybe for like coding, I just Google. I I learned a lot from a lot of templates online. Just get like a small portion of that because I might need that step, and then incorporate that into my code. And for problems like facilities, I guess Michael just mentioned that facility equipment, I usually just read protocols for like 10 or 20 minutes. If I still can't figure out how to do that, I just go to the facility director. Yeah, so it depends. My approach depends much on the problem itself. New stuff, just reading and discussion. Pretty much that. The other thing, just ask people. Yeah.
okay. So PhD is not done in a vacuum, is what you're saying. There's a whole team that comes along and helps us too.
Yeah. I mean, for new stuff, just everyone is just guessing. So this can happen, that can happen, and also some people can analyze that this way, that way. So if you analyze this way, the result might be different from the other approach to analyze that. So new thing is just no one can give the real help. You just have to get suggestions from everyone, and then you come up with something that makes sense and persuade people, I guess.
Mm-hmm.
Yeah.
Okay. And Andrew, how about when you come across the challenge?
I'll add in some thoughts because I think a lot of the challenges are different. Like homework challenges is going to be different than equipment challenges. It's going to be different than unexpected research results. I think my strategy isn't like a step one, step two. It's kind of like, okay, there's the problem and you're trying to do it. So they kind of just recognize it, I guess. And then instead of letting the problem bug you, try to just not rule anything out. And then usually I try to come up with some sort of idea what's going on, whether it's right or wrong. It doesn't actually matter to me. I'll just if it's research, I'm just looking at it. Maybe you'll think something super crazy, I don't know, something's reacting with this for some reason. You don't really know. But now you think maybe there's a reaction happening, for example, even though nobody would, that's not the first thing you would think to expect. Similar with equipment, you could just be looking at the equipment and it's not working. Maybe you think it's a certain piece, and that's just your hunch. So for now, you're okay, that's my hunch. And you kind of think about it a bit. And then if I still have the problem, I try to get some sort of idea of what I think it is. Again, it doesn't matter if it's at all right or if it would be the first guess by people. And then I try to get, I guess, other ideas. And then I think that is usually worked out for me. So usually, I guess I would ask some of my friends. I'll ask lab mates, my advisor, and usually I try to just say what I'm thinking and why, and get more insights. And then I think it's important to just not rule out problems, especially, or not problems, what you think couldn't happen. So not assuming things to be true or not assuming things to be the case until they're either proven or etc. And I think that's especially true for research, because that is definitely new things. And if you start assuming things, it can go not great. So I don't know. Don't let research like surprise you, and just keep working towards a solution. Just try to make any progress. If you're trying new things, then like I think that's good. If you're doing like nothing, then that's the only thing that can be a problem. So any progress is good progress, I guess. I don't know.
And don't, like you're saying, is don't let the results or your biases influence what your observations are. Have an open mind. Come out with you should come out with an estimate first, right? And hypothesis, but you might prove your hypothesis wrong. Yeah.
Yeah.
Okay. Do we have any other questions?
Yes, we do. Larry, would you like to ask your questions?
Yes. Hi, Larry Luster, rising senior, chemical engineering major from Hampton University. I actually have two questions. I'll ask them both if time permits. But first one is about your qualifying exam at CCNY. So first, like, how are they conducted for the chemical engineering program, and how was preparing for your qualifying exam different than preparing for any exam that you had in undergraduate?
Who would like to take this? Andrew, you're
I probably can.
So you want to do that?
Yeah, it was, I guess, the most recent for me. So from what I recall, it is like a literature critique. So what happened is like we had a 2-week span. Like on the first day, you're given, I think it was 4 different papers. And what you have to do is you pick a paper and you have to write like a 5-page critique, as well as prepare, I think it was 20 minutes presentation. And let's see, in the first few days, I think they wanted us to tell them which paper we selected, or maybe not the first few days, but once you know, like let the advisors know which paper you have selected. And then the report kind of speaks for itself. You have like the summary of the paper, the critique, and a future work section. And I think I pretty much just followed that, 3 different sections for the report. And then the presentation, I did the same layout, like intro, I had background, then like summary, critique, and future work. And what the goal was is to focus on like the fundamental areas of chemical engineering. So you can focus on like the reactor/kinetics, thermodynamics, fluid mechanics, and anything else that could be in your paper. Maybe it's like interfacial phenomena, or etc. For the presentation, you do it in front of 3 professors. You give your 20-minute roughly presentation, and I think it's followed by 30 minutes or 20 minutes of a question period, which sounds pretty long, but it is over pretty quickly. Well, it feels quicker than it is. And the questions can be challenging or simple. There's usually a focus on like the general chem ends principles, like the fluid mechanics and the thermo and kinetics, as well as things that are just relevant to the paper. Some of it will just be on the paper. Some of it will be like writing things on the board. Maybe it's equations, maybe it's like a reaction scheme, a diagram would be like an example would be like a phase diagram. I think that came up in mine, as well as mine had a lot of heat transfer. So I had to write a few like heat transfer equations on the board. They kind of ask you about it, like what's this term? Like, can you explain it this way? Putting up the phase diagram for what was in the paper and explaining something the authors have said or stated. Maybe they ask you to go more in depth of why you've made a certain critique point. And your goal is to try to answer these as best you can. I think a good advice for this, because it can be, it makes you pretty nervous, because I don't know, fundamental chemical engineering off the top of your head can be challenging sometimes. And when you're explaining like something you haven't done for, well, I mean, you studied, but you haven't like taken the course for a couple of years or 3 years or more, if there was like a gap between undergrad and PhD. So usually it's good to actually just think about the questions. Like the professors give you time to think. It's not really like a super rush. So start thinking first, and then say your thoughts out loud, just so they know you're making some progress. You can start writing on the board if it's a board question, but just kind of going, like you can go slower and work your way through the problem. It's not like you just have to know the answer right away. If you do, that's very impressive, but that's not the goal. It's to work through it. And yeah, that was, I think, the process.
Have you ever had an exam like this before?
No, not really. I think the closest could be like a undergrad thesis. You give a presentation on work, and you'll have like the professors ask questions about the research, and they can ask about like ChemEng. I think at my school, they went out of their way to try and do that. They would ask more challenging questions sometimes. They knew we were like undergrads at the time, so they wouldn't ask like the same things they would ask to their PhD students doing their like second exam or thesis defense, but they would try to get us to think on our feet about, I don't know, kinetics or fluid mechanics or et cetera. And they would also like challenge what we said just so we would defend it. And I think that's probably the most similar. And that only happened like once or twice in my undergrad for like the thesis defense or undergrad thesis and like the practices for the undergrad thesis. And yeah.
Okay, and also I think we can move on probably to the next question here, but you also got a chance to practice and do some practice critiques in the first semester of your time at CCNY, correct?
Yeah, we did a few recruit reports and a presentation at the end.
Okay, great. If it's okay with you guys, I'm going to move on to the next question. I think Andrew covered that pretty detailed.
Yeah. Larry, let me give Keegan a chance to ask his question, then we'll come back to yours. Is that okay?
All right, sounds good.
Good. Keegan, go ahead.
Thank you. My question is, how did you guys end up choosing your research group? Like, what factors did you guys find important? What brought you guys to the field that you're at? And what was the process like?
Okay, go ahead.
Sure. Yeah, I can go. Right. Obviously, like I said, I work with David Romtinsky, who studies kind of models biological processes, I guess, but with a very kind of physics approach, I guess, is how I would put it. Well, how I picked him out was when I first, came to, actually even when I applied, one thing you should all do is, of course, look at the faculty there. You can easily suss out who's in what area of research. I was kind of interested in biology, so there were, I guess, a few researchers, but I looked at his, and I looked at one of the papers, which was this really long and complicated thing about atherosclerosis, which is the hardening of blood vessels. And it was basically a model where you had talking about basically how sometimes they have gaps, and I'm going into much detail. Anyway, I looked at the paper. It it had a diagram of the blood vessel. It also had a bunch of equations, a lot of which I didn't understand. But I think I like the approach. You can kind of tell right off if you kind of like the approach taken on the paper, I guess. I like the approach of, here's a system, we can look at the physics of it, at the of the flow, and get some equations to describe it, and then we can do some experiments to test those equations. And that's basically what I wanted to do. And when I got into City College and came, it was pretty clear to me that I was gonna work with David. Yeah.
How about Jaylun? You have a response?
Yeah, I do. So, in my case, I did an internship that internship started like 3 months before the application for the program. And the internship was to do lab work in Dr. ChE Chen's group. So I guess that's pretty much like a rotation. Like a lot of students go to every different lab and try out different things. So I have tried out Dr. ChE Chen's lab before I applied for the program. And then I guess that the topic interests me a lot. The bigger picture is for some sustainable energy. I think that's cool. But then, so I chose his group. Of course, the work I do now is very different from the work I've done during the internship. But still, I think the passion just drives me to keep working on this. And also, I think apart from the topic, I think I can get along with my professor, my advisor. Yeah, so I think it's fun. So I have passion on the research, and professor is fun. So I guess that just kind of work out on my side.
Okay.
Yeah.
And Andrew, how about you?
I think what's important, like you want to be working with a group that you can get along with, and you want to work on a topic that you care about. I think it's not like how do I want to say it? Like, try not to stress too much about finding like the perfect thing you want to work on, like the exact topic, etc. Like, I think it's good to be like pretty open-minded. It doesn't have to be like the exact thing you want to work on. You just want to work on something that interests you, and you want to have like a group that you can work with. And if you have that, I think the PhD will be like a good time. And then like after that, you can move in, like you can change topics now, and you can go do, or you can try to like find a job or more research in like the exact topic that you want to work in, or like a topic you want to work in more, or etc. But kind of first step is, I don't know, getting through the PhD and like enjoying that enough that you want to keep doing whatever you want to do next.
And when you started at CCNY, you all had a chance to learn more about our research before joining a group. So you could, even if you had a pretty good idea in mind, you still got a chance to learn what else was going on and see if there was something else and you wanted to work on, or found a research group that was going to be the right fit. Because you all also mentioned, how it's important to find the right match between research group and your own personality and such, right? Okay, thank you. Shall we take that last question?
Yeah, we have one more question. Larry?
Okay, so this question, I guess, kind of builds off of the answers that you were giving to the last one. So as you've progressed through your candidacy, how important has your relationship with your advisor and your committee members been?
Who would like to start?
Yeah, I guess I'll go ahead. All right. I think obviously it's interesting. I think I liked what Ji-Loon said earlier about coming up with ideas, right? Or maybe Andy said it, where you kind of develop a rapport with your mentor where you talk things through, and you've encountered a problem, and you describe it, and then you make some suggestions, and then you talk about and then eventually you kind of iterate through and get to a solution. That is, I think, the most important part of having that mentor relationship, I guess. Being able to just talk with them, trusting in their expertise, and even when they're not an expert at certain things. For example, David is not a biologist, right? In background. So, even in those situations, you still, it's good to talk to them, and they can still be very helpful because of the depth of the of literature is read, but also because you can kind of maybe pose the problem in a way that is easier for you to understand. So I think it's that cycle of discussions is really the most important thing to build. And it even became more interesting for me because last year David was away on a sabbatical, right? So our relationship, like it is now, really is by on Skype. So then it really became about just keeping in touch and having interesting discussions, right, every week, and kind of yeah. So okay, hopefully that answers some of your questions.
Lynn or Andrew, would you like to contribute to that at all?
Yeah. For me, I think the relationship between a professor and me it doesn't really matter. I mean, by the end of the day, he'll decide if you can graduate or not. But my progress is my progress. And also, for a short period of time, say a month or two, it doesn't really matter. Because we have talked a lot already. So if he just disappear, go on vacation for 2 months, doesn't really matter. But for a long run, maybe after this project, if I have to come up with new ideas, or maybe like just simple ones, or change direction, I still have to talk to him. But that's not like pretty urgent. That doesn't mean that we have to talk a lot every day. And yeah, that's pretty much how I deal with my professor. And also, I guess he just talked to me a lot. So his disappearance hasn't happened. And also for other lab mates, they're helpful because that's more like mentally support. A lot of mentally support, and also so my project for the demonstration parts. So I make material, and we have to demonstrate that this material is good. For the demonstration part, we have a lot of overlapping. So their experience can be very, very helpful for my project as well. So yeah, that's pretty much my answer.
Andrew?
Yeah.
Thank you.
Yeah. I think like the relationship with like you have the professor as well as the like lab mates is very, very valuable. Like from the time I started the PhD to now, like I guess like when I first started the PhD, it's a new experience. Like sure, I've taken classes before and I've done some research before, I've been in a lab before, but this is, I don't know, it's still very, very new. You're balancing a lot of things. You're trying to get like better at writing, know how to like come up with your own research, get through these classes, and etc. And the people that have done it before are your advisor and like the lab mates. So they're like very good for like getting advice, kind of like knowing what's going on, and like making like good progress like throughout the PhD. If you kind of just go at it alone and like try to do everything without help, it can be very, very hard. And yeah, once you get through like a couple of years, you kind of have like a much better idea. But I think there's like always things to learn, and the people that are like your advisor, and if you have like more senior members in your lab group, are like the ones who have gone through that, so they can help you. And then once there's like new people in your lab group, you can kind of reinforce what you've learned by helping them or teaching them. And I think it's kind of things, maybe, I don't know, it's not every, like, how do I say? You kind of get surprised by the PhD and like what's going on and the things you have to do. And I don't know, going in, you can be like, yeah, maybe I can do it. And then you kind of realize like, well, it's challenging. So probably I'm going to go ask for some help and like take advice and, you know, try to just get input and better at, I don't know, the PhD from the people that have the PhDs.
Okay. So I think we're about out of time here. I want to really thank Yinka, Jairun, and Andrew for joining today, and for Professor Kouzis for helping to co-moderate. I'm going to actually share my screen one more time just to go over a couple of things before wrapping up here. Let's see, make sure I shared the right one. Okay, yes. So can you see that? There we go. So this is the talk that we gave today, but I just want to point out that last week we gave another talk that was on our conversation that was on why to pick do a PhD, and that is available on YouTube. And then, if you go to our department website, you can find that. I'll also send a link out after we've archived this talk on YouTube as well. We have a lot of successes in the department, and so I just wanted to point out some of the successes we've had: faculty awards and funding and publications. And all of these guys contribute to this as well. And then our research areas, we really covered quite a bit of this today: energy and environment, biomolecules and biotechnology, energy and interfaces. And there's Andrew actually in the picture too, right? And that, you know, these guys are all also covered by competitive stipends and tuition coverage. So you don't have to take out loans or anything to do a PhD. And I just have some notes about the application deadlines here. But I want to thank everybody again for participating, for attending, and please reach out if you have any other questions. And I'd like to say, have a great rest of your day. Thank you.
Stay safe, guys.
Thank you
so much.
Thanks, everyone.
All right, thank you.
Thank you.
Thanks for coming.
Yeah.
Okay, they've all left.